Hello, good morning dear students. Welcome to today's class. In the last class we have started the refraction part in the ray optics. Today we are going to continue that class and welcome to today's class. So let's start. Okay. So we were discussing ray optics. Ray optics. Okay. So today we are going to see the laws of refraction. Okay, laws of refraction. Laws of refraction. Okay, so first law of refraction is incident ray, refracted ray, and normal all lie in same plane at the point of incidence, at the point of So this is the first law of refraction, and just like your law in reflection. Allenu hengitiri incident ray, reflected ray, and normal all lie in the same plane. Adu same incident ray, refracted ray, and normal all lie in the same plane at the point of incidence. So this is this first law of refraction. Means one plane nalli irutte. Suppose it is in xy plane. So everyone will be in xy plane. Like this one. Okay, second law of refraction is nothing but it is called as Snell's law. What does it say you? Snell's law. Sine of angle of incidence, the ratio of sine of angle of incidence to the sine of angle of refraction is constant. What is that? Sine of angle of incidence, that is sine I by sine R, is nothing but constant. So this is the Snell's law. That is ratio of sine of angle of incidence to the sine of angle of refraction is constant, and that constant is nothing but relative refractive index, that is n to 1. Right? Again we can write sine I by sine R is equal to n2 by n1. Right? Again we can write n1 sine I is equal to n2 sine R. Okay, so this is the second law of refraction. Okay, so sine I by sine R is equal to constant. And this equation, that is n1 sine I is equal to n2 sine R, is nothing but generalized Snell's law of refraction. Generalized equation of Snell's law of refraction. Okay, law of refraction. So n1 sine I is equal to n2 sine R. So this is the equation, generalized equation. Okay, now just see here, sine I by sine R is equal to n2 by n1. Right? We know this, sine I by sine R is equal to n2 by n1. Suppose what is this? Suppose the light is traveling from air to glass. Okay, this is air, this is glass, right? So this is n1, this is n2, right? So this is normal. So we know this is angle of refraction and this is angle of incidence. Okay, so here the ray is traveling from air to glass. So this is n1 and this is n2. So air, we know refractive index of air is nothing but 1. So n1 is equal to 1 here. So if you substitute n1 is equal to n1, that is sine I by sine R is equal to n. Why I am writing n? Because there is only one refractive index, that is of glass, and it is something, I don't know how much it is. So therefore sin I by sin r is equal to n. Whenever there is one medium is air, whenever the first medium is air, then its refractive index is 1, okay, and second medium we have sin I by sin r is equal to refractive index of second medium, okay. So this is the Snell's law, and right. So this is the law of refraction, laws of refraction. Now let's see one more thing. That is the relation between N21 and N12, right? The relation between N21 and N12. So I am taking one glass here. So this is a glass and it's having refractive index N2, and this is N1. Now I am taking one ray of light which is incidenting here. So this will be the normal, okay. So after this, refraction will take place, so the ray will bend towards the normal, okay. So this is the angle of incidence, this is angle of refraction, okay, right. So from this first case, what we can write? Snell's law, sin I by sin r is equal to N2 by N1. Sin r by sin r is equal to N21, and we know sin I by sin r is equal to N2 by N1. N21 is nothing but N2 by N1, okay. Now what I am doing, I am keeping one mirror here. On mirror, I am keeping one mirror here. So mirror ittidre, what will happen? This ray will again go in the same direction. So at this time, the ray is traveling from this denser medium to rarer medium, right? Glass in the air ge paas agakatiti. In this case, the ray is going from rarer medium, that is air, to the glass. Now I am putting one mirror here. So this mirror will again sends back this ray here, okay. So this will become incident ray now. This will become incident ray now. So again in the second case, what will happen? So this is the incident ray, and this is the angle of incidence, and this is the angle of refraction, that is sin I means angle of incidence. In second case, the angle of incidence is nothing but r, okay, divided by sin. In second case, see, this is the angle of incidence for second case, and this is the angle of refraction. So finally sin r by sin I is equal to N2. So now the ray is traveling from N2 to N1, okay, N2 to N1, glass to air, okay. In this case, the ray was traveling from air to glass. So we have taken N21. So now the ray is traveling from glass to air. So we have to take N12, right? So finally what we can write? Sin r by sin I is equal to N1 by N2, right? So take it as equation number 1, take it as equation number 2. Now multiply 1 and 2. Multiply 1 and 2. What will get? Sin I by sin r into here sin r by sin I, right, is equal to N21 into N12, N21 into N12, right? So this cancel, this cancel. So finally what we have? 1 is equal to N21 into N12, right? So finally we can write N21 is equal to 1 by N12. So this is the relation between N21 and N12. I hope you understood this. So let me repeat this once again for you. We know sin I by sin R in this case, sin I by sin R in the first case. We are taking two cases here. First case is incident ray is traveling from air to glass, and in second case the incident ray is traveling from glass to air. Okay. So see, in the first case the ray is traveling from air to glass. At this time sin I by sin R is equal to N21, and in second case the ray is traveling from glass to air. Hence this angle becomes the angle of incidence and this angle becomes the angle of refraction. Therefore sin R by sin I is equal to N12, right? Sin R by sin I is equal to N12. Okay. Now multiplying 1 and 2, sin I by sin R into sin R by sin I is equal to N21 into N12. So finally N21 is equal to 1 by N12. Okay. So this is the case. I hope you understood. Let me tell you some general things. Okay, see. So whenever we are talking about the refraction, so yesterday I have said you what is rarer medium and what is denser medium. Now the ray is here, this is the incident ray, this is the normal, right? So this is the refracted ray. So this is angle of incidence, this is angle of refraction. Okay. So there are two cases when first one is ray travels from rarer to denser. Okay. And again second case, ray traveling from denser to rarer. Okay. We know what is denser and what is rarer medium. Okay. So when the ray is traveling from rarer to denser medium, in this case the ray is traveling from rarer to denser medium. See, so this is the air, this is glass, and we know glass is denser than air. Glass is denser medium and air is rarer medium. So this is rarer and this is denser, right? Now the ray is traveling from rarer to denser. In this case what happens? When the ray is traveling from rarer to denser medium, the angle of incidence is greater than angle of refraction. Okay. Andre, the ray will bend towards the normal. Again one more point. Second point, ray bends towards the normal. ಏನಾಗುತ್ತಂದ್ರೆ, so whenever the ray, when it is traveling from rarer to denser medium, ಏನಾಗ್ಬಿಡುತ್ತೆ, so the ray will bend towards the normal. See, this is the normal, and the ray actually its path is like this. See, actually the ray will pass in straight line, we know. Okay, so actual path of this ray is in this direction, but it is bending due to refraction. Again, ಯಾಕೆ ಈ ಸೈಡ್ ಬೆಂಡ್ ಆಗಕತ್ತೈತಿ? ಬಿಕಾಸ್ ದ ರೇ ಇಸ್ ಪಾಸಿಂಗ್ ಫ್ರಮ್ ರೇರರ್ ಟು ಡೆನ್ಸರ್ ಮೀಡಿಯಂ. ರೇರರ್ ಇಂದ ಡೆನ್ಸರಿಗೆ ಬರಾಕತ್ತೈತಿ, ಅದಕ್ಕೆ ದ ರೇ ಈಸ್ ಬೆಂಡಿಂಗ್ ಟುವರ್ಡ್ಸ್ ದಿ ನಾರ್ಮಲ್. ದಿಸ್ ಈಸ್ ದಿ ನಾರ್ಮಲ್ ಕಡೆ ಬೆಂಡ್ ಆಗುತ್ತೆ. ವೆನ್ ದ ರೇ ಇಸ್ ಪಾಸಿಂಗ್ ಥ್ರೂ ರೇರರ್ ಟು ಡೆನ್ಸರ್, ಇಟ್ ವಿಲ್ ಬೆಂಡ್ ಟುವರ್ಡ್ಸ್ ದಿ ನಾರ್ಮಲ್. ಓಕೆ, ರೈಟ್. And finally, if the ray is bending towards the normal, then angle of refraction is less than angle of incidence, or angle of incidence is greater than angle of refraction. So this is the 2 points to remember. When the ray is traveling from rarer to denser medium, there are 2 points to remember. First one is the angle of incidence is greater than angle of refraction, and the second one, it will bend towards the normal. Finally, these two are related. See here, when the ray will bend towards the normal, then definitely the angle of refraction will be less than angle of incidence. Okay, now let's see this case. Okay, sorry. Ray travels from denser to rarer. Sorry. In this case, the ray is traveling from denser to rarer. So I'm sorry. So here, angle of incidence is greater than angle of. I should write it here, refraction, and finally it will bend towards normal. Towards normal. Sorry. So here in this case, ray is traveling from rarer to denser medium. In this case, angle of incidence is greater than angle of refraction, and the ray will bend towards the normal. Now let's see the second case. Suppose this is a denser medium, say glass, and this is air. Okay, so this is rarer, this is denser. Okay, so I am sending one ray. This is the, I am sending one ray. So this is the incident ray, and we know this is denser medium. So therefore, the ray is passing from denser to rarer medium here. So this is the normal. So when the ray is traveling from denser to rarer medium, suppose this is angle of incidence. So actual path of this ray is like this. See, here the actual path, actually, if there was no glass or there was no air, then actually the ray will pass in the straight line. Glass or medium idre, so it will go in this direction, straight line. Okay, so actual path of this ray is like this. But when the ray is traveling from denser to rarer medium, it will go away from the normal. So it will go like this. And in this case, what will happen? It will go bend away from the normal. Normal in the dur hogbidutu. Away from the normal. Okay. ಈಗ one thing observe ಮಾಡಿ, if it is going away from the normal, then definitely the angle of refraction will be greater than angle of incidence. ನೋಡ್ರಿ ಯಾವ angle greater ಐತಿ? So in this case, angle of refraction is greater than angle of incidence. Okay. So when the ray is traveling from denser to rarer medium, what will happen? When the ray is traveling from denser to rarer medium, angle of refraction will be more than angle of incidence, and it will bend away from the normal. So it will bend away from the normal. So normal in the dur hogbidutu. So this is nothing but the one of the things to remember whenever you are learning the optics. These are very important concepts, and these will help you in doing a lot of things, in understanding a lot of phenomena. It will help you a lot. Okay, so just remember these 2 points. When the ray is traveling from denser to rarer medium, the angle of refraction will be more than angle of incidence, and it will bend away from the normal. In this case, when the ray is traveling from rarer to denser medium, the angle of incidence will be more than angle of refraction, and it will bend towards the normal. So this was the 2 points to remember. Okay, don't get confused in the rarer and the denser medium. Okay, rarer medium is the one. Rarer medium ಯಾಕೆ ಹೇಳ್ತೀವಿ, denser medium ಯಾಕೆ ಹೇಳ್ತೀವಿ ಅಂದರೆ, so the medium which is having higher value of n is denser medium. Okay, n value, refractive index value ಯಾವುದು ಜಾಸ್ತಿ ಇರುತ್ತೆ, so it is that medium is denser medium, and refractive index value ಯಾರ್ದು ಕಡಿಮೆ ಇರುತ್ತೆ, ಅದು that is nothing but the rarer medium. Okay, so this is the phenomenon. Just remember this, and we have seen ನೀವು ಕೇಳಬಹುದು ಸರ್ ರಿಫ್ರಾಕ್ಷನ್ ಜನರಲಿ ನಾವು ಎಲ್ಲೇ ನೋಡ್ಬೋದು ಅಂತ ಕೇಳ್ಬೋದು. ಸೊ ಯು ಹ್ಯಾವ್ ಸೀನ್ ಇಫ್ ಯು ಪುಟ್ ಅ ಕಾಯಿನ್ ಆನ್ ಬಕೆಟ್ ತಗೋರಿ, ಅದ್ರಾಗ ನೀರು ಹಾಕಿರಿ, ಓಕೆ, ಒಂದು ಕಾಯಿನ್ ಹಾಕಿರಿ ಇಲ್ಲೇ, ಓಕೆ. ವೆನ್ ಯು ಪುಟ್ ದಿ ಕಾಯಿನ್ ಆನ್ ಇನ್ ದಿ ಬಕೆಟ್, you can see, if you see, the coin will appear somewhere upward here like this. ಸ್ವಲ್ಪ ಮೇಲೆ ಬಂದಾಗ ಬಕೆಟಿಂದು ಟಾಪ್ ಮೇಲೆ ಬಂದಂಗೆ ಕಾಣುತ್ತೆ. You will feel that the bucket has become shorter and the coin has came up ಮೇಲೆ ಐತೆ ಅಂತ ಕಾಣುತ್ತೆ. So that is nothing but the refraction of light, okay. So that is nothing but the refraction of light, and we have seen lot of phenomena things we can observe the refraction of light, okay. But see, this is the earth and this is the star. Due to refraction, this is the actual position of a star. But whenever you are here on this earth, okay, when you are here on this earth, you will see the star at this position. ಈ ಪೊಸಿಷನ್ನಾಗಿ ನೀವು ಸ್ಟಾರಿಗೆ ನೋಡ್ತೀವಿ, ಬಟ್ ಆ್ಯಕ್ಚುಲಿ ದ ಸ್ಟಾರ್ ಈಸ್ ಆ್ಯಟ್ ದಿಸ್ ಪೊಸಿಷನ್, ಇಲ್ಲೇ ಐತಿ, ಬಟ್ ನಿಮಗೆ ಇಲ್ಲೇ ಕಾಣುತ್ತದೆ. ಯಾಕಂದರೆ ಡ್ಯೂ ಟು ರಿಫ್ರಾಕ್ಷನ್ ಆಫ್ ಲೈಟ್ ಏನಾಗಿಬಿಡುತ್ತೆ, ಲೈಟ್ ರಿಫ್ರ್ಯಾಕ್ಟ್ ಆಗಿ. ಸೊ ಫೈನಲಿ ಯು ವಿಲ್ ಫೀಲ್ ದ್ಯಾಟ್ ದ ಸ್ಟಾರ್ ಈಸ್ ಹಿಯರ್, ಬಟ್ ಆ್ಯಕ್ಚುಲಿ ದ ಪೊಸಿಷನ್ ಆಫ್ ಸ್ಟಾರ್ ಈಸ್ ಹಿಯರ್, ಓಕೆ. ಸೊ ಇನ್ನೊಂದು ಏನಂದರೆ, ಸಪೋಸ್ ಒಂದು ಬಕೆಟ್ ತಗೋರಿ, ನೀರು ಹಾಕಿರಿ, ಓಕೆ. ಪೆನ್ಸಿಲ್ ತಗೊಂಡು ಅದ್ರಾಗ ಹಾಕ್ರಿ ಆ್ಯಂಡ್ ಸಿ ದ ಮ್ಯಾಜಿಕ್, ವಾಟ್ ವಿಲ್ ಹ್ಯಾಪನ್. ಅರ್ಧ ಪಾರ್ಟ್ ಪೆನ್ಸಿಲ್ ಎಷ್ಟರ ಮಟ್ಟ ಏರ್ನಾಗಿರುತ್ತೆ ಅಷ್ಟು ನಿಮ್ಗೆ ಕಾಣುತ್ತೆ ಸರಿಯಾಗಿ. ನೀರಿನಾಗ ಹೋಗಿದ ತಕ್ಷಣ ಜಸ್ಟ್ ಅಲೈನ್ಮೆಂಟ್ ಚೇಂಜ್ ಆಗಿಬಿಡುತ್ತೆ, ಚೇಂಜ್ ಇನ್ ಅಲೈನ್ಮೆಂಟ್. ಜಸ್ಟ್ ಗೋ ಆ್ಯಂಡ್ ಅಬ್ಸರ್ವ್ ಇಟ್, ಮಾಡಿ ನೋಡಬೇಡ್ರಿ. ಸೊ ವಿಲ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ವಾಟ್ ಐ ವಾಂಟೆಡ್ ಟು ಸೇ. Okay, so these kind of things we have seen, and this is due to refraction of light. And ಮತ್ತು ಇನ್ನೊಂದು, ನೀವು ಸನ್ರೈಸ್ ನೋಡ್ತೀರಿ, ಸನ್ಸೆಟ್ ಎಲ್ಲ ನೋಡ್ತೀರಿ. ಸೊ ಆ್ಯಕ್ಚುಲಿ ಯು ಡೋಂಟ್ ಸಿ ದ ಆ್ಯಕ್ಚುಯಲ್ ಸನ್ರೈಸ್ ನೋಡೋಂಗಿಲ್ಲ ನೀವು ಆ್ಯಕ್ಚುಲಿ. ಯಾಕಂದರೆ ಡ್ಯೂ ಟು ರಿಫ್ರಾಕ್ಷನ್ through the atmosphere. Nodri, this is the earth, it contains some atmosphere aital, so there is some atmosphere, right? So atmosphere iddud karana enagutte, this medium will become denser medium. Atmosphere is denser medium, and this is vacuum, this is rarer medium, okay. Vacuum is rarer medium and this is atmosphere is denser medium. Enagutte, actually the sun was here, but you feel the sun is here, okay. So you actually sunset and sunrise ನೋಡ್ತಿರಲ್ಲ, sunrise ಏನು ನೋಡಕತ್ತಿರಲ್ಲ, so that sun is not the real sun that you are seeing, okay. Actually ನೀವು 2 minutes ಆದ್ಮ್ಯಾಗ ಅದು ನೋಡಕತ್ತೀರಿ. Actually that sun that you are seeing is not the real sun, it is nothing but the image. So it will be 2 minutes before ಆ್ಯಕ್ಚುಯಲ್ ಸನ್ರೈಸ್ಗಿಂತ 2 ನಿಮಿಷ ಬಿಫೋರ್ ನೀವು ಸನ್ ನೋಡ್ತೀರಿ. ಸೊ ಆ್ಯಕ್ಚುಲಿ ದ ಸನ್ ಈಸ್ ಬಿಲೋ, ಮೀನ್ಸ್ ಡ್ಯೂ ಟು ರಿಫ್ರಾಕ್ಷನ್ ಯು ವಿಲ್ ಸಿ ದಿ ಸನ್ 2 minutes ಅರ್ಲಿಯರ್. ರಿಫ್ರಾಕ್ಷನ್ ಸಲುವಾಗಿ ನೀವೇನು ನೋಡ್ತೀರಿ, 2 minutes ಅರ್ಲಿಯರ್ ಸನ್ರೈಸ್ ನೋಡ್ತೀವಿ. ಸೊ ದಿಸ್ ಈಸ್ ದಿ ಕೇಸ್, ಆ್ಯಂಡ್ there are a lot of applications of refraction. If possible we'll discuss in upcoming classes. So till that, have a good luck and keep in touch and study well. Don't lose confidence, don't lose the hope, and try work harder. So thank you guys, thank you for watching, and work hard. So don't stop doing work. Thank you. Good luck.